Welcome guys to the Rust tutorial. In Rust, variables are like frozen walls. Once you declare it, you just can't change it simply. We have to add mute so that we can change it. While const, it creates an eternal monolith. Rust favors immutability to prevent bugs. If code assumes that a value won't change, Rust ensures it doesn't. And with this, in Rust, this makes your logic easier to reason about. Time to get our hands dirty. Fire up your terminal and enter cargo new variables. We are initializing a fresh sandbox to push the limits of Rust's safety engine until it screams. No more theory, let's build. Now step inside main.rs. We bind x to 5, a simple solid start. But then we break the silence and try to reassign to 6. In most languages, this happens in total silence, but not in Rust. Inside your terminal, enter cargo run. The compiler hits back with an error. You cannot assign twice to an immutable variable. It's a guardian, it's not an obstacle. In Rust, safety starts with immutability by default. To allow a variable to change, you must be explicit. Adding the mute keyword isn't just syntax, it tells the compiler and every developer reading your code exactly where data is designed to be modified. No hidden side effects, just intentional controlled mutability. Then there are constants. They aren't just immutable, they are eternal. Unlike variables, constants are always immutable and can never use the mute keyword. They are baked into the very fabric of your program. Constants demand two non-negotiable rules. First, you must use screaming snake case for their naming, making them impossible to ignore. Second, they require an explicit type annotation. Rust leaves zero room for ambiguity when dealing with its most permanent value. This is absolute clarity. Constants are set to expressions that the compiler calculates before the program even runs. It's free work for your CPU performed at the forge during compilation. By the time your code executes, the hard work is already done. But what if you want a fresh start without the overhead of mutability? Enter shadowing. By using the let keyword again, we aren't just changing a value, we are spawning a brand new variable that steps out of the darkness to completely obscure the previous one. The old data is still there, but it's now hidden in the shadows. One cool thing about shadowing is that it lets us perform transformation while keeping the final results immutable. We take the old value, add one and bind it to the new identity and it works. And we can do many other transitions. Shadowing also works within nested scopes. New block with curly brackets can shadow variables to temporarily override value or type. Once execution reaches the closing bracket, that inner value is dropped and the original binding from the outer scope is completely unchanged. This is the beauty of shadowing. Shadowing provides a distinct safety benefit over mutability. Because shadowing uses the let keyword, the resulting variable is immutable by default. This protects your logic from accidental reassignments further down the line. While mute allows continuous change, shadowing ensures that once a transformation is complete, the data remains fixed and secured. Shadowing's ultimate flex: changing types. You can shadow a string of spaces into a numeric count using the same name. A mute variable is locked to its original type forever, but shadowing lets you evolve your data structure instantly. We have mastered change. From frozen statues to shape-shifting shadows, Rust gives you total control over how your data lives and dies. And this is the foundation of system engineering. Variables are just containers, but what do they actually hold? Next time we dive into the building blocks of code, and that is data types. Don't miss the next drop. Hit that subscribe button and join the journey. See you in the next one.